Hello there and welcome to my channel. In this video, we'll be discussing the topic superposition in DC and AC circuits. Now let's start. When we talk about superposition, we can think of superposition as a divide and conquer strategy. Instead of solving a complex circuit all at once, we look at each power source one by one. So we turn off all the sources except for one and calculate the response and repeat that for every source in the circuit. To get the final answer, we use a phasor sum. Because AC electricity has both a size and a direction, we can't just add them like regular numbers. We add them like vectors using the magnitude and phase angle. In a DC circuit, inductors act like simple wires and capacitors act like total gaps. This keeps things easy because we only have to deal with basic resistance. But when we talk about AC circuits, everything shifts over time. We use phasors to track the timing of those waves and complex impedance to see how inductors and capacitors react to the frequency. Basically, DC is a constant flow, but AC is all about managing the rhythm and phase. In this example of a phasor diagram, we can see that there are two phasors, E01 and A02. E01 has a phase angle of alpha 1 and E02 has a phase angle of alpha 2. Since AC quantities can have different phase angles, we cannot add them like normal numbers. Instead, we treat them as vectors and add them geometrically. When the two phasors are added using vector addition, we obtain the resultant phasor E0. This resultant has its own magnitude and phase angle alpha, which represents the combined effect of the two AC sources. Now, in diagram B, we can see that there are horizontal and vertical components. Horizontal components are E01 cos alpha 1 and E02 cos alpha 2, and the vertical components are E01 sin alpha 1 and E02 sin alpha 2. To find the resultant phasor, we add the horizontal and vertical components together. These combined components determine the magnitude and the direction of the final phasor E0. Now let's do the simple question. It asks us to find the V0 of the following circuit using the superposition theorem. So this is V0 is actually V total simply. And here you can see an AC voltage source, AC current source, and a DC voltage source. And as you can see, I've noted down the amplitude and the angular frequency for each. So as you can see, we need to find V0 or Vt by adding up V1, V2, and V3. Now, as you can see, this is step 1. So the 5-volt DC source remains as it is, but we short circuit the AC voltage source, which was a 10 cos 2t voltage source, and we make the AC current source 2 sin 5t amps, that one, we make that as an open circuit. Now, as you can see here, there are the rules for DC system. For a inductor, it's supposed to be short circuited. For the capacitor, it's supposed to be an open circuit. So that's the reason why here we have made the 0.1 farad capacitor as an open circuit. And here you can see that the polarity is from positive and negative here. So the current flows in this direction. So since it's going from positive to negative, we have taken the value of V1 as negative in our calculation. But overall, when we solve it using voltage divider rule, we find out that V1 has a positive value, which is 1 volts. Now we're going to move on to step 2. Here the AC voltage source remains as it is, and we short circuit the DC voltage source and open circuit the AC current source. Here, as you can see, we find out how we can convert the 0.1 farad to minus J5 ohms. Here I've taken the liberty to show the calculations for Z1, which is impedance 1. So I'm going to go through that. So in order to convert from the rectangular form to the polar form, this is how you do it. Now here we find V2 by using voltage divider rule. So this is the final answer we get for V2. As you can see, the AC current source remains as it is, and we short circuit the DC voltage source and also short circuit the AC voltage source. And here we calculate V3. As you can see, it's shown how we convert 0.41 farads to minus J2 ohms. And here, as you can see, the minus J2 ohm capacitor is in parallel with the 4 ohm resistor. So I'll also show the calculations for this. This is how you find the rectangular form of Z2, which is impedance 2. And these are the steps for finding the polar form of C2. Now here, by using current divider rule, we can find out the value of V3. As you can see, these are the calculations for V3. Now finally, we calculate V0, which is the total sum of V1, V2 and V3. So this is the final answer. With this, we come to an end to this video. Thank you so much for watching.